Hello everyone, my name is James Heslington and today I'm doing the presentation on ensuring quality in the design and installation of hoisting systems prior to shaft construction. So a brief overview of the agenda that we'll cover today. So we'll start with the hoisting plant background, essentially just discussing where the technology has changed over the past 2 centuries. And I'm going to dive into the engineering basis. So basis of design, design and review, who's involved, the best practices in the design of hoisting system. Then we'll look at the quality side of things with regards to the installation. So planning, fabrication, the foundation construction itself, the equipment, installation, so that's both mechanical and electrical disciplines. Also, I want to discuss the survey requirements. So again, something that's changed a lot, specifically with regards to quality and precision. For quality inspections itself, that's QA and QC. That's focusing on the construction. However, obviously the commissioning is when we move towards operation. So very important to discuss both the function and performance of that hoisting system before we use it in a permanent phase. The maintenance is also quite an important thing that I want to cover. Although not necessarily before the shaft construction, I think it's important to discuss. It's also just a main consideration when we go forward to operations and the future longevity of that hoisting system. Then I will close out the presentation with any final considerations and closing remarks. There'll be a quick question session at the end. So, in terms of where hoisting has come from and where it's going, so there are a few key things that have happened over the last 2 centuries. Obviously, the advent of steam being very, very critical to that, and then moving more towards the electrical changeover, electrical motors, and whatnot. Hoisting started with manual means, so manual operation winching, hoisting, and obviously using animals, your horses, your donkeys, and then we move towards that steam technology. So each time we see a technology advance, obviously capacity, safety, and also installation means have changed significantly. Not just the hoisting systems, but also the ropes themselves. Changing rope technology have also allowed us as a mining sector to go deeper and also ensure a higher level of safety. Regulation gets thrown in there as well. And although I don't really talk too much about regulation in this slide, except for obviously the safety integrity level systems at the end, it's obviously very key. With all these technology changes come new regulation. One thing I do want to mention is certainly in the early days, the Levant disaster was a very key incident that occurred. The man engine itself, obviously essentially was a form of transport, again used instead of a hoisting system for transporting works into the mine. That large disaster resulting in 31 people dying, that really helped move the sector in general, and hoisting systems actually learnt lessons from that. Although not directly linked, there were some key learnings from that. So, basis of design, determining the fitness for purpose. This is the first question we should ask before designing any hoisting system. This talks operations and the function. The main question I always have is how many tons a day? These are your user requirement specifications. If you can't have the output in operations, then the hoisting system isn't fit for purpose. No, we have to think about the mine life itself. Are we going to consider hoisting or haulage? Before we even get into the design, we might look at conveyors, other haulage solutions instead of just hoisting. So the operations team, the end user, will define those key points before the design starts. Ultimately, a lot of the design basis is driven by the legislation as well. So unfortunately, regulation is written in blood. We've had multiple incidents over the last 2 centuries, and each time technology, legislation will change slightly, and designs will obviously be updated to suit. Especially now, we're seeing with safety integrity levels, SIL systems, that's really changed how we view safety, especially the control systems for the hoisting plant. Again, going back to the last slide, when we look at the history, when we've changed from steam to electric, there's also vast changes with the basis of design. Whether or not you're using extensive pneumatic systems, your power requirements on site. Combined with that, you have the PLCs, so your control system. So how are we being safe with regards to braking, and obviously hydraulic systems. So all of this is a consideration into that design basis. One big thing, and especially this presentation focusing more pre-shaft construction, is to consider the sinking and permanent phase. These are two distinct separate phases. Every day in shaft sinking equates to money lost. We're talking about $100,000 a day. So every day or every piece of schedule saved in the sinking phase results in a closer production date. So having separate sinking permanent phases, you might have a quicker sink, but then it's going to cost a lot more money. You're going to have two separate sinking plants. So there's a bit of a trade-off there, and again, that basis of design, you need to consider the cost, the schedule, and ultimately, what is that fitness for purpose? So with regards to design and review, who's involved, what are the deliverables, what are the best practices? So you have multiple stakeholders involved in any design for a hoisting plant. So that's OEM, the operations team, the third-party hoisting engineers. One big thing that we need to discuss is obviously the constructability, maintainability, and lessons learned. This isn't just from the company or from other sites, from the sector in general in the country or national, but we really need to think about how other things can input. We have multiple systems. Look at the picture there. We have the overhead crane. So how can we optimize that design with regards to the hoisting system? Although not, part of that system, the hoist, is still obviously a key consideration. Once we have the operational parameters defined and the duty cycles confirmed, then obviously we can dive into the details. That's when I like to bring in the operational team, discuss those lessons learned from previous installs, whether it's accessibility to bolts or whether it's having an access door, things like that. Disciplines need to communicate and coordinate. We have HVAC, we have the civil side of things, electrical. Always laugh, instrumentation, electrical always comes last. But certainly when you're doing a civils design, whether you have cable and piping routings above ground, below ground, hoist pit, no hoist pit, these are all things that tie into the constructability and also that initial design. Management of change is key, and I'm going to mention that a few times through this presentation. When we think about quality, managing change properly ensures the end user knows what has happened, and also the client. You as an engineer, you as a site team, a project team, you need to make sure you know what's changing, whether it's cost, budget, or just standard engineering practice. The quote I always love to say is, "The pen is mightier than the sword," and that's something we've seen change a lot over the last century, certainly in the mining sector. Unfortunately, documentation is key now, and that management of change, documenting, ensuring that any legacy installs, keep that quality. That's very, very important. So planning. When we talk about the project management triangle, schedule, quality, budget, um, we can see multiple examples where we've missed one in the world and had disasters. Think about the Challenger disaster. That's always a good one to bring up. We do need to consider these three things when doing a hoist install, because there's lots of different factors that can improve or decrease productivity. So winter installations are, for some reason, I always seem to do hoist installs in winter when it's minus 40 outside, but it's obviously very challenging. You have temperature fluctuations, you have the sideways freezing rain, especially in Canada. It introduces lots of challenges. Sequencing is also a big one. Do you install the hoists before or after the hoist house? You have different approaches to craneage, mobile craneage, or the hoist house itself. With the building for the hoist house, do we stick build? Do we group assemblies and try and do large lifts? We talk about tandem lifts with mobile cranes, install the roof as one. So as a project team, really what I like to do is consider how I can improve schedule where needed. You might spend a bit more on craneage to do these larger lifts, but you can bulk that together as long as your schedule's running properly. Yes, the crane will be more, but the overall schedule is less. And again, going back to what we said in the previous slide, a quicker date to operations. The mine can make money faster. Required on-site dates are keys. For me, I like to work back from that. What's your ROS date? Once you have that, then you can backdate, see your engineering, see your fabrication, go from there. The hoist house construction, you talk about a year, year and a half. So there's a lot of moving parts, a lot of disciplines involved. The planning needs to involve multiple stakeholders, not just the hoist system on its own. The other thing worth talking about for planning is just contingency. Carrying that budget. So if there are field changes, management of change, like we said, how can we capture that at later date? We're talking about 10, 15% just in case. So fabrication, this is really where you make sure the due diligence is there. So factory acceptance testing will be the final sign-off, your sign-off release before the equipment is released to site. So the plan is key. Going to factory acceptance tests without proper checklists, without proper tooling, you won't get the full result from that inspection. And that's when issues could come through at a later date. The sign-off release, removes the liability, not just for the OEM, not just for the site team, but any key stakeholders. So again, that's a very important thing to make sure that is done. Laser scanning, talk about survey in a few slides' time, but new technology. It's a very good reference to have that. You can incorporate it into your 3D models or just general as-builts. The tolerance isn't necessarily there with laser scanning. There's obviously far more precise methods. But as an overall cross-check, I find it to be very valuable and something I will always do. The supplier's document requirement list and master deliverables registers are always defined early on. So I'll do that in the scoping phase. What that means is throughout the project, I can then track progress, see what documents are defined, and then when we come to the final handover or the factory acceptance, we know what we should be checking. It's very easy to come to the FAT and say, we need these documents and just hand over a big list. But ultimately, OEM won't be 100% clear. You won't be 100% clear. Other stakeholders might bring in different documents, and it can lead to confusion. Define it early, track them as you go through, and then at the end, there's a nice, clear handover with co-signing. Obviously, visiting the shops is key. The more, certainly for myself, I encourage my team to go to the shops where they can, the better the inspections, the better the quality of the install. You can catch things in the shop, especially if you do full install. Buying a hoist or a winch that hasn't been pre-built in the shop, full assembly, you run a risk. Is there fabrication tolerance? Is there something, that you wouldn't see when the quarters are fully assembled? So that's why it's really important to get to those shops, see a full assembly, and stay on top of the OEM themselves. Obviously, one other thing that is key to mention is third party versus your own as a project. Things like your NDT testing, that'll be your third party qualified members, stakeholders, whether it's a third party design engineering firm or whether it's your own designers. Again, key consideration, people take to the FAT. You want as many key stakeholders at those visits as possible who add value. Obviously, when you have a large hoist install, you have to be there for the photo at the end as well. So the foundation construction is essentially one of the first activities on site when you're actually breaking ground. So documentation is key here, especially within Ontario, the construction permits and the involvement of the city. It really, really is important to make sure everything's documented, your material records, your as-builts for your pour, especially with concrete. I like to do a pre-pour and a post-pour install inspection. Because the foundation is permanent, that also brings a slightly different approach to quality. You talk about sinking versus permanent phase hoisting systems. Well, the foundation stays there for forever. So we really do need to make sure that everything is captured throughout this phase. So when I talk about that, I'm thinking, pouring in winter versus summer. Is there a risk of shrinkage cracking? Do we need to vibrate? Is it a large pour? Are there any joints? Certainly with foundation, we want to avoid joints where possible, and when we're talking hoisting. But when you are having large pours like that, talking 600 cube plus, those are things that have to be considered. The wobble tubes themselves, it's fairly standard practice, I would say now, helps transition the loadings through the foundation, but it really helps give a bit of tolerance. Especially for the constructors, there will be a construction tolerance that needs to be considered. You'll always have a plus minus on the bolts themselves and that wobble tube. Obviously, once you're finally set, you grout them in and you're good for the install itself. Talk about foundation construction again. Field changes. We'll keep coming back to management of change, but the importance of having the engineers in the field being on top of that foundation, whether it's surveys, whether it's bolt checks, just general inspections on the rebar and whatnot, with a final sign off, very important. So with regards to equipment installation itself, I'm really going to focus on the mechanical discipline first. We will start at the design considerations. So, fitness for purpose, future needs, maintenance, accessibility, especially with regards to your preventative maintenance, mechanical really drives here. When we are doing the annual inspections of the hoist, we need to be able to see the bolts, get into the drum. When we do final hoist replacements, and this is well after the operational phase has been ongoing, can you access the nuts? Or do you have to go and fully derope every time and start torching? Hopefully not. With the factory visits, and again we're going back to the factory acceptance, we start mechanical, we'll do the measurements, we'll do the checks, and then on site, obviously baseline measurements are key. With regards to the pre-commissioning phase, want to make sure everything's really ready to go. So you can fill gearboxes now with essentially with an oil with additives. That means you can have it pre-filled during the shipping phase, storage, and then you can actually use it at a later date. It prevents spending more money on two different types of oil and avoids the risk of mistaking that oil that was used for storage for permanent operation. Electrical, it always comes last, let's be honest. But when we are proactive, you work side by side, you can really be quite efficient in those installations. It's not just hoisting as well with electrical. We also have to consider the shaft, the site infrastructure, so track limits, shaft obstructions, design basis. Can we access the track limits? Are you able to go up there easily without going on the crosshead? Is there an access platform? Things like that. A high risk all this installation, not just mechanical, not just electrical, but especially with electrical because we're bringing in site-wide power. It's high risk to machinery and obviously personnel. Livening up notices, nice standard control of works. It goes side by side with the permit to work system. Just prevents you from bringing online something too early that hasn't been properly walked over. So as part of my quality inspections, I always make sure that will form part of your inspection test plan. One of your key hold points will be that livening up notice. Until all the key stakeholders have signed off, you will not proceed to energization. The inspections. A lot of hoisting equipment comes from around the world these days. And that's actually equipment in general in the mining sector. So if we, especially in Canada, if we're bringing equipment from overseas, do we have the CSA, ESA certification? Planning wise, that can also impact what we're doing. When we talk about risk to schedule and risk to projects, bringing these items, if there isn't awareness of those requirements, especially with ESA, that can cause detriment to the project. When we talk about suppliers document requirement lists, STRLs, we have that defined at the scope of work phase. So the suppliers know that is a requirement before the equipment is delivered to Canada. It really helps speed up everything. Future proofing, again, very standard throughout this, but especially with advancing technology, PLC systems, for example, licenses, need to plan ahead. Make sure the equipment doesn't become obsolete and there's spare parts availability. Still a lot of change in surveying. Old, new techniques. I don't think there's a right or a wrong way, but a combination is definitely best. With installs, you'll always have a heavy field bag. To name a few: plumb bobs, calipers, line lasers, piano wire, and all of these different methods will result in a quick, efficient, and quality installation. Same thing with modern techniques. A total station, a digital level. If you aren't aware of the tolerances and the required quality, then there are vast risks associated with that. Um, you can certainly have machines that can get knocked in the field. I mentioned the cold earlier. You'll see fluctuations in the accuracy of that machine. One day you'll have a certain tolerance, and then the next day it will completely change, and that's due to a plus 10 degrees or minus 10 degrees temperature difference. We can pick up a lot of these survey methods in the FAT itself. So the laser scan we spoke about previously, making sure there are scribe lines on the equipment, so machine services for leveling, scribe lines for drum center or frame center. It all helps with making that installation efficient. Third-party checks, very important, especially when we're talking about primary control and secondary control. The project team will always be responsible for the survey when it is very precise surveying, like obviously a hoist install. That's when I like to get a third-party check done. We'll come do a quick check on your primary control and then obviously run some checks on the hoisting install itself. Gives you a bit of confidence as an installer, and also for any key stakeholders, it's a cross-check. Removes liability where possible. So quality inspection, this is QA and QC. Two very different roles, but obviously both play together, very, very important. The best engineers are the ones seen in the field. Can help with the installations, can be there to react to any issues, and capture the lessons learned. So future installs, you have the knowledge. You have the knowledge from working, but then also you have all the scheduling and the engineering behind you. It's very, very important, especially with hoisting installations, few and far between, especially with large packages. So to see those engineers, just to stop what they're doing for a bit, go out in the field and work along the teams, it's invaluable. Especially the first hoist install, you give someone a brush and greasing the rope as you're roping up. It's a very rewarding task. Again, being in the field, that's not just through the construction phase, it's also fabrication. So visiting the shops, getting that relationship with the machine shops, with the OEM, and then also the factory acceptance test at the end. Generating the efficiency lists throughout the process. Again, when you come to completion, it's nice and easy. Make sure you're tracking any punch items, category A, category B, category C. I don't like to use the category C. Obviously, category A items being you cannot proceed to commissioning without completion. Category B, you cannot hand over. You can't hand over to operations without completion. And then category C is after operations it can be complete. I don't like using that because it's never going to get done in reality. So A and B, commissioning versus operations at final handover. Audits, internal audits. So I'll always have my teams do internal audits on themselves or third party. If possible, bring in a third party, audit your procedures, audit your quality. It really helps dive into that hoist installation itself. Again, that can be the third-party hoisting engineer. Review the designs, audit some of the key specs, and also the installation. Make sure you have all quality documentation to hand. Rework, most important thing. We want to avoid it. It costs time and money. So commissioning is obviously a big collaboration between all those key stakeholders. Um, that's why defining the delegation of authority early on is key. You don't want people stepping on each other's toes. You don't want confusion here and there. So we define that before construction, again, in that early scoping phase. Only two phases for commissioning: rope on, rope off. Um, Clearly defined, make sure the tasks are clear, and then have sign off before the next phase. Again, talk about the hold points, the inspection test plans. This is really where it all comes together. Roping up is great. Not only is it part of that commission activity, but also you can start doing your operational checks. You can train your hoist operators. So not just the quality of the install, but also the quality of future operations and safeguarding the skills. Schedule is very critical for commissioning because you'll be pulling in different activities across site, whether it's electrical, mechanical. So we really need to track that quite closely. Baseline measurements are the most important thing. Not just talking, vibration, temperature, speeds. But in the future, if things go wrong, we can always come back to that baseline and compare against. Very, very important. Red lines, always done by the project team. Any changes you've done, again, management of change, like we said before, you capture it at this phase, and that will form part of that final pack. Commissioning, you're bringing all that final pack together, your nice hard copy binder, and that'll be ready for the handover to the operations team. So maintenance is very important, especially, preventative maintenance, and that's why I like the getting ahead of the curve type analogy. Plenty of legacy hoists have no documentation. And when you go to do work on them in the future, you're trying to work out certain routings or key original specifications. So collect it as you go. Obviously now, especially certainly in Ontario with the logbooks, there's a lot of liability, a lot of accountability on the workers to complete those logbooks. And they're very useful. It's not just a regulatory requirement, but as an operator, it helps you. So being on top of them, again, auditing, certainly from the maintenance side, very important to go through them, make sure they're filled out correctly and the information is correct. Standardizing lubricants. I mentioned earlier about the storage of oils, but the standardization throughout site can also assist, help save money, help save schedule. Especially when you have multiple bearings on site, multiple hoists, you're going to one OEM for the whole supply. With regards to the completions packs, I always like to have a hard copy available on site. That's good for visits. If the MOL come to site, you have it available. Also, to have a digital copy. So again, that's what you'll send over to the client for future records, whatever it might be. But having those two side by side really does help. You always have a quick reference on site if needed, guide people to that, and then digital obviously is a lot easier in terms of record keeping. Storage requirements, we'll talk about spares. Do we have to rotate things? Do we have to grow grease, bearings? Do we need access to the crates? Some crates can be boxed up, left for months. However, some you'll be pulling them out every 6 months during inspection. So again, also very key consideration. Instead of just leaving crates in the side or corner of a warehouse or even outside, we actually need to know what is being used for and clearly marked up. So some final considerations just to wrap up the presentation then. So the significance of the design considerations for the transition from sinking to production phases are key. It impacts both budget and schedule. There's also safety involved. Less activities in theory means less risk. Fitness for purpose will keep budget, schedule, and quality on track for the requirements of the phase. Sinking setups are temporary. They don't have the same inputs as the permanent systems, but vice versa. They're both separate. Teams must ensure involvement of the construction operations team. Talk about lessons learned. Very, very important. If those engineers are on site, they can learn themselves, they can implement on the next project. Regulatory requirements for hoisting are critical and must be respected. Goes without saying. Legislation written in blood, and we all have a part to play in ensuring safe operations. That ties in with training as well. It's not just, making sure the designs are correct, but are the workers trained properly? Are the method statements in place? People know what they have to do. Legacy/older equipment must be properly maintained and records kept. Again, we've spoken to that quite extensively throughout this, making sure we have the quality packs available really, really does assist with future maintenance activities, future change outs, and just understanding what you have on site. It's also contingency. When we talk about obsolete equipment, whether it's your PLC, your drives, we can plan ahead, we can future proof equipment. And then finally, people who are present in the field can witness the challenges and assist with future work. Direct feedback from people in the field, straight up to management, straight up to future designers. Keep that action tracker, keep that log of things that were changed, whether it's quality, safety, schedule, budget, and then you can apply that to all future installations. So just a quick overview of some of the references used, obviously just there for everyone. And that wraps up the presentation. So thank you very much for listening. Obviously, please feel free to reach out to myself with any further questions or any scope that might be involved with your project. Thank you.